team number is 6, and me and my team members are going to talk about when machine learning goes off the rails. So my team members are myself, Preet Lakhani, Varun, Srikant, and Spencer Louis. So as we know that in the right now in the tech industry, machine learning is booming. So we have decided to talk about when machine learning goes off the rails. So, what happens when machine learning computer programs that absorbs new information and then change how they make decisions leads to investment losses, bias hiring, or landing or car accidents. Should business allow their smart products and services to autonomously evolve, or should they lock their algorithms and periodically update them? If firm choose to do the latter, when and how often should those updates happen? And how should companies evaluate and mitigate the risk posed by those and other choices? So, moving forward across the business world, as a machine learning based artificial intelligence parameters more and more offerings and processes, executives and boards must be prepared to answer such questions. In this article, which draw on our work in healthcare law, ethics regulation, and machine learning, we introduce a key concept for understanding and managing the potential downside of this advanced technology. So, what makes machine learning risky? The big difference between the machine learning and the digital technologies that preceded it is the ability to independently make increasingly complex decisions, such as which financial product to trade, how vehicles react to obstacles, and whether a patient has a disease, and continuously adapt in the results to new data. But these algorithms don't always work smoothly. They don't always make ethical or accurate choices. There are three fundamental reasons for this. So first and foremost is simply that the algorithm typically rely on the probability that someone will say default on a loan or have a disease. Because they make so many predictions, it is likely that some will be wrong just because there's always a chance that they will be off. The likelihood of errors depends on the lot of factors, including the amount and the quality of the data that is used in the trained to the algorithm, the specific type of machine learning method chosen, for example deep learning, which use complex mathematics models versus a classification trees that rely on decision rules, and whether the system uses only explainable algorithms, meaning humans can describe how they arrived at their decision, which may not allow it to maximize accuracy. The second reason is the environment in which machine learning operates may itself evolve or differ from what the algorithms were developed to face. While this can happen in many ways, two of the most frequent are concept drift and uh, covariate shift. With the former, the relation between the inputs the system uses and its outputs isn't stable over time or may be misspecified. Consider a machine learning algorithm for stock trading. If it has been trained using a data only from a period of low market volatility and high economic growth, it may not perform well when the economy enters a recession or experience turmoil. Say, during a crisis like the COVID 19 pandemic, as the market changes, the relationship between the inputs and the outputs, for example, between how leveraged a company is and its stock returns, also may change. Similar misalignment may happen with the credit scoring models at a different points in the business cycle. In medicine, an example of concept drift is when a machine learning based diagnosis system that uses skin images as inputs in detecting skin cancers fails to make correct diagnosis because the relationship between the color of someone's skin and the diagnosis decision that hasn't been adequately captured. Such information often is not even available in the electronic health record used to train the machine learning model. The second one is covariate shifts occurs when the data fed into an algorithm during its use differ from the data that trained it. This can happen even if the parameters of the algorithm learn are stable and there's no concept drift. For example, a medical device company may develop its machine learning based system using data from large urban hospitals. But once the device is out of in the market, the medical data fed into the system by care providers in the rural areas may not look the development data. The urban hospitals might have a higher concentration of a patient from a certain socio-demographic groups who have underlying medical conditions and not commonly seen in rural hospitals. Such disparities may be discovered only when the device make more errors while out in the market that it did during testing. Given the diversity of market and the pace at which they are changing, it is becoming increasingly challenging to foresee what will happen in the environment that system operate in, and no amount of data can capture all the nonsense that occur in the real world. So how should we? So from now, one of my team member will take care of it.
So how should we program an autonomous car to value the lives of 3 elderly people against, say, the life of one middle-aged person? The third reason machine learning can make inaccurate decisions has to do with the complexity of the overall systems it's embedded in. Consider a device used to diagnose a disease on the basis of images that doctors input, such as IDXDR, which identifies eye disorders like diabetic retinopathy and macular edema, and was the first autonomous machine learning based medical device authorized for use by the US Food and Drug Administration. The quality of any diagnosis depends on how clear the images provided are, the specific algorithm used by the device, and the data that the algorithm was trained with. Whether the doctor was inputting the images, received appropriate instruction, and so on. With so many parameters, it's difficult to assess whether and why such a device may have made a mistake, let alone be certain about its behavior. But inaccurate decisions are not the only risk with machine learning. Let's look now at two other categories: agency risk and moral risk. Agency risk. The imperfections of machine learning raise another important challenge: risks stemming from things that aren't under the control of a specific business or user. Ordinarily, it's possible to draw on reliable evidence to reconstruct the circumstances that led to an accident. As a result, when one occurs, executives can at least get helpful estimates of the extent of their company's potential liability. But because machine learning is typically embedded within a complex system, it will often be unclear what led to a breakdown, which party or agent, for example, the algorithm developer, system developer, or a partner, was responsible for an error, and whether there was an issue with the algorithm, with some data fed to it by the user, or with the data used to train it, which may have come from multiple third-party vendors. Environmental change and the probabilistic nature of machine learning make it even harder to attribute responsibility to a particular agent. In fact, accidents or unlawful decisions can occur even without negligence on anyone's part, as there's simply always the possibility of an inaccurate decision. Executives need to know when their companies are likely to face liability under current law, which may itself also evolve. Consider the medical context. Courts have historically viewed doctors as the final decision makers and have therefore been hesitant to apply product liability to medical software makers. However, this may change as more black box or autonomous systems make diagnoses and recommendations without the involvement of, or with much weaker involvement by, physicians in clinics. What will happen, for example, if a machine learning system recommends a non-standard treatment for a patient, like a much higher drug dosage than usual, and the regulation evolves in such a way that the doctor would most likely be held liable for any harm only if he or she did not follow the system's recommendation. Such regulatory changes may shift liability risk from doctors to developers of the machine learning enabled devices. The data providers involved in developing the algorithms, or the companies involved in installing and deploying the algorithms. More risk. Products and services that make decisions autonomously also need to resolve ethical dilemmas, a requirement that raises additional risk in regulatory and product development challenges. Scholars have now begun to frame these challenges as problems of responsible algorithm designs. They include the puzzle of how to automate more reasoning. Should Tesla, for example, program its cars to think in utilitarian cost benefit terms or Kantian ones, where certain values cannot be traded off regardless of benefits? Even if the answer is utilitarian, quantification is extremely difficult. How should we program a car to value the lives of three elderly people against, say, the life of one middle aged person? How should businesses balance trade offs, say, privacy, fairness, accuracy, and security? Can all of these kinds of risk be avoided?
Moral risks are also included bases related to demographic groups. For example, facial recognition algorithms have difficult time identifying people of color. Skin, ca- skin classification systems appear to have unequal accuracy across race. Recidivism predication instruments give black and false high rating and credit scoring system given them low justly low ones. With, with many widespread commercial uses, machine learning systems may be deemed unfair to certain groups on some dimensions. The problem is compounded by the multiple and probably mutually incompatible ways to define fairness and encode it in algorithm. A leading algorithm can be calibrated, meaning that its decisions are independent of a group identity after controlling of risk level, while still disproportionately denying loan to creditworthy minorities. As a result, a company can find itself in a damned if you do, damn if you don't situation. If if it uses algorithms to decide who receives a loan, it may have difficulty avoiding the charges that it discriminating against some groups according to the one of the definitions of fairness. Different cultures may also accept different definitions and ethical trade-offs. A problem of products with global markets. A February 2020 European Commission white paper on AI points to these challenges. It calls for development of AI with European values. But will such AI be easily exported to regions with different values? Execute, Executives need to think of machine learning as a living entity, not as an inanimated technology. Finally, all these problems can also be caused by model instability. This is a situation where inputs that are close to one another to decisions that are far apart. Unstable algorithms are likely to treat very similar people very differently and possibly unfairly. All these considerations, of course, don't mean that we should avoid machine learning altogether. Instead, executives need to embrace the opportunity it creates while making sure they properly address the risks. To lock or not to lock. If leaders decide to employ machine learning, a key next question is should the company allow it to continuously evolve or instead introduce only tested and logged versions at intervals? Would the later choice migrate the risks just described? This problem is fairly to medical world. The FDA has so far typically approved only softwares as medical devices whose algorithms are locked. The reasoning agencies has not wanted to permit the use of devices who diagnose products or treatment pathways keep changing in ways it doesn't understand. But as FDA and other regulations are now realizing, locking the algorithms may be just as risky because it doesn't necessarily remove the following dangers: inaccurate decisions. Locking doesn't alter the fact that machine learning algorithms typically base decisions on estimated probabilities. Moreover, while the input of more data usually leads to better performance, it doesn't always, and the amount of improvement can vary. Improvements in unlocked algorithms may be greater or smaller for different systems and with the different volumes of data. Though, it, though it's difficulty to understand how accuracy of decisions may change when an algorithm is unlocked, it's important to try. Environmental changes. It also matters whether and how the environment in which system makes decision is evolving. For example, car autopilots operate in an environment that are constantly altered by the behavior of other drivers. Pricing, credit scoring, and trading systems may face a shifting market regimen where the business cycle enters a new phase. Challenging challenge is ensuring the machine learning system and the environment coevolution in a way that lets the system make appropriate decisions. Agency risks. Locking.
Locking an algorithm doesn't eliminate the complexity of the system in which it's embedded. For example, errors caused by using inferior data from third party vendors to train the algorithm or by differences in skills across users can still occur. Liability can still be challenging to assign across data providers, algorithm developers, deployers, and users. Moral risks. A locked system may preserve imperfections or biases unknown to its creators. When analyzing mammograms for signs of breast cancer, a locked algorithm would be unable to learn from new subpopulations to which it is applied. Since average breast density can differ by race, this could lead to misdiagnosis if the system screens people from a demographic group that was underrepresented in the training data. Similarly, a credit scoring algorithm trained on a socio-economically segregated subset of the population can discriminate against certain borrowers in which the same way that the illegal practice of redlining does. We want algorithms to correct for such problems as soon as possible by updating themselves as they observe more data from subpopulations that may not have been well represented or even identified before. Conversely, devices whose machine learning systems are not logged could harm one or more groups over time if they are evolving by using mostly data from a different group. What's more, identifying the point at which the device gets comparatively worse at treating one group can be hard. A toolkit for executives. So, how should executives manage the existing and emerging risks of machine learning? Developer appropriate processes, increasing the savviness of management and the board, asking the right questions, and adopting the correct mental frame are important steps. Treat machine learning as if it's human. Executives need to think of machine learning as a living entity, not as an inanimate technology. Just as consecutive testing of employees won't reveal how they will do when added to a pre existing team in a business, laboratory testing cannot predict the performance of machine learning systems in the real world. Executives should demand a full analysis of how employees, customers, or other users will apply these systems and react to their decisions. Even when not required to do so by the regulators, companies may want to subject their new machine learning based products to randomized control trials to ensure their safety, efficacy, and fairness prior to rollout. But they may also want to analyze products' decisions in the actual market, where there are various types of users, to see whether the quality of decisions differs across them. In addition, companies should compare the quality of decisions made by the algorithms with those made in the same situation without employing them. Before deploying products at scale, especially but not only those that haven't undergone randomized controlled trials, companies should consider testing them in a limited markets, to get a better idea of their accuracy and behavior when various factors are at play. For instance, when users don't have an equal expertise, the data from sources varies or the environment changes. Failures in real world settings signal the need to improve or retire algorithms. Think like a regulatory and certify first. Business should develop plans for certifying machine learning offerings before they go to market. The practices of regulators offer a good roadmap. In 2019, for example, the FDA published a discussion paper that proposed a new regulatory framework for modifications to the machine learning based software as a medical device. It laid out an approach that would allow such software to continuously improve while maintaining the safety of patients, which includes a complete assessment of the company or team developing the software to ensure it has the culture of organizational excellence and high quality that would lead it to regularly test its machine learning devices. If companies don't adopt such certification process, they may expose themselves to liability, for example, for performing insufficient due diligence. Many startups provide services to certify that products and processes don't suffer from bias, prejudice, stereotypes, unfairness, and other pitfalls. Professional organizations such as the Institute of Electrical and Electronic Engineers and the International Organization for Standardization are also developing standards for such certification. While companies like Google offer AI ethics service that examine multiple dimensions, ranging from the data used to train systems to their behavior to their impact on well being, companies might need to develop a similar framework of their own. Monitor continuously. As machine learning based products and services and the environments they operate in evolve, companies may find that the technologies don't perform as initially intended. It is therefore important that they set up the ways to check that technologies behave within the appropriate limits. Other sections can serve as models. The FDA's Sentinel initiative draws from disparate data sources such as electronic health records to monitor the safety of the medical products and can force them to be withdrawn if they don't pass muster. Businesses will need to establish their own guidelines, including ethical ones, to manage the new risks. And luckily, the journey to develop and implement principles doesn't need to be lonely one. Machine learning has tremendous potential, but as its technology, along with other forms of AI, is woven into our economic and social fabric, the risk it poses will increase. For business, mitigating them may prove as important as and possibly more critical than managing the adoption of machine learning itself. If companies don't establish appropriate practices to address these new risks, they are likely to have trouble gaining traction in the marketplace.